So what is matching? You can think of matching as a grouping that has less variability or more homogeneity within the group than between groups in your data set. So does it mean they were all matched? Yeah, we're definitely more similar among humans on the globe than we are to Martians. If the universe is our data set, we're definitely going to be more similar than anyone else in the universe. So here's a word of caution. When you match on a factor, even though you might not realize it, you are implicitly also matching on all of the other variables associated with that particular factor. So for example, if you compare a subject before and after, then you match on that subject. But you also match on age, genetic makeup, environmental factors, hair color, shoe color, etc. Or for example, if you match on age, then you're going to also match on all the diseases that increase or decrease with age. You're going to match on education or job level, cumulative drinking history, family status, number of times you took an exam. And essentially what you could be doing, you could be overmatching. So I was writing once a grant application on after stomatitis, or these are canker sores that occur in about almost 40% of the US population. And these occur very similarly in males and females. There is no gender predilection. However, the peak prevalence is age 11 to 15 during growth spurt. So the question would be, if I was planning to conduct a case control study, should I have matched on gender? And also, should I have matched on age? So when I submitted the grant application, the reviewers asked me why I didn't match, and I didn't match on either gender or age. So the grant application was rejected. So then I resubmitted it, and I explained the reasons. I didn't match on gender because if after stomatitis is similar in males and females, then there is no need to match on gender. Just by recruiting individuals from the population, this was like a campus, university campus, I would have gotten pretty much males and females. And also, because the disease occurs even in males and females, there is no link. If you think about the directed acyclic graphs, there is no link between the disease and gender. In addition, I was recruiting participants from a college campus, and so I was expecting just about everybody to be have a similar age. And that is, in fact, the grant then was funded, and that is exactly what happened. I didn't match on anything, and I had perfect distribution of gender, and the cases and controls had essentially the same age. But you need to be careful about overmatching. So if you're matching on a factor that is not a confounder of disease exposure association, then we are overmatching. And that would have been the case if I started matching on characteristics like gender in the previous case. And so there are potential problems we can create when we match. For example, if the factor is related strongly to the exposure, what we will do, we will make the cases and control more similar on exposure, and we said do not touch the exposure. So what we're going to do, we're going to create a bias toward the no. The two groups will become very similar. And the factor is related only to the disease, so it wouldn't be a confounder. And lastly, the factor may be an intermediate. And this is very serious, because now we're matching on a factor that is an intermediate, and that can cause quite a lot of problems. You can imagine that.